Everyone, and thanks for taking time to attend this data bite. For those who don't know me, I'm Ravi. I'm a senior managing consultant at Altis. I'm currently part of Altida product team, working very closely with Anup on product side of things. So if you pay attention to the title of the data bite today, so it's image analytics using Altida, OpenFlow, and Cortex AI. There is quite a bit of jargon here, Altida, OpenFlow, and Cortex AI. And if you guys are new to Altis, or if you haven't had a chance to work with Snowflake, then definitely these terms, they look alien to you. So here is how I structure my presentation. So just give me one sec. Okay, so I'm going to spend 5 minutes to give you a quick intro to Altida, OpenFlow, and Cortex AI, because I'll be using these terms throughout my presentation. And then we look at the actual demo, followed by any Q&A. So firstly, what is Altida? So Altida is our Altis's in-house product. So it's been developed completely in-house. And it's a metadata-driven ETL framework, which has been designed to accelerate the data engineering processes, right? So when I say data engineering, that includes both ingestion and transformation. So you can think of Altida as a rapid application delivery for your data pipelines. And here is the architecture for the Altida. So with Altida, you can use any ingestion tool of your choice, whether that could be ADF, Matillion, Talent, or even OpenFlow, to connect to the data sources, land the data into the data lake. That could be your Azure Blob Storage or S3 or even Snowflake internal stage. So once the data is in data lake, Altida will pick it up and it will and it will populate your landing zone, persistent stage table zone, and even your transformation layer. So the entire schema management is done by Altida. So data engineers are not writing even a single piece of DDL while they're building the pipelines. Okay, so what is OpenFlow? So OpenFlow is Snowflake's native data ingestion tool. So it can process any data that you throw at it, whether that could be structured, semi-structured, and unstructured data like audio video files, IoT sensor files, documents, images, etc. Right? And it's built on the top of Apache NiFi, which is an open source software. And here is the architecture of Altida and OpenFlow, with Altida with OpenFlow. So it's exactly the same as the previous slide, but the only difference here is ADF has been replaced with OpenFlow. Now OpenFlow will connect to the data sources, land the data into the data lake, and once the data is in the data lake, the architecture for the Altida is not changing. Okay. So now what is Cortex? Cortex is a broad topic. It's such a huge topic in Snowflake. But if I have to explain what Cortex is in one simple line, in one simple sentence, you can think of Cortex as a Snowflake's native AI and machine learning framework. Okay. And what is Cortex AI SQL? So it's a new feature within Snowflake. It allows users to interact with LLMs or LVMs using standard SQL. So LLMs are large language models which have been trained using text. LVMs are large vision models which have been trained using images. So with Cortex AI SQL, you can interact with both those models. So what this ability means, like Cortex AI SQL, what it actually meant for Altida team. So it has actually opened the doors for our team to integrate Altida to integrate AI into Altida pipelines. And that's what exactly we have done with this image analytics. So this is how you interact with an LLM or LVM using Cortex AI SQL. So at the top, you can see a simple select statement calling AI complete function, where I'm passing in the name of the model that I want to use. And I'm telling the model that go and analyze this image, which is sitting, sorry. Yep, sorry. So go and analyze this image, which is sitting in this S3 bucket. But the crux here is the prompt. So within the prompt, I'm putting all the instructions, like what attributes I want to capture out of this image, and I'm even telling that I'm even telling LLM that I want the results to be spit out in a strict JSON format. So when you run this SQL query about, you'll see the results a JSON result being spit out as per the second screenshot here. So this capability is huge for us because this is what exactly we need. When you have the results in the JSON format, you can store this JSON in the S3 bucket, and from there, Altida will pick it up, and then it will start populating it can populate your persistent stage table zone and the transformation layer. Okay, so this is how the underlying architecture works for the Altida image analytics pipeline with OpenFlow. So anyone who worked with Altida, they know that it's a metadata-driven tool. So what that means is you configure your meta in a database table. Once that happens, the OpenFlow pipeline will read the prompt from your extract meta. We call that as an extract meta table. It will read the prompt from the meta table, and then it calls the Cortex AI SQL wrapper function that we built. Okay, that will spit out the JSON results and stores that into a data lake. So once the data is in data lake, Altida will pick it up, and then it will persist the results into a stage table. So this is how the underlying architecture for the image analytics works. Enough of theory. So now let's get into the practical demo. Okay. So in this demo, what I'll be demonstrating is I have a bunch of car damage images, right? If I'm a claims assessment officer working for a car insurance company, my day-to-day task is to analyze these images, visually inspect them, record my findings in the database, and take the action accordingly. When I say taking action, that could be like sending a tow truck to pick up the car or whatever it is, right? But now what we're going to do, we're going to do exactly the same thing using AI. So we put all these images through the AI pipeline and get the AI to capture the results for us. Okay, so here are a bunch of car damage images that I have got. Okay, and these are publicly available from Kaggle website. Okay, so this is one example. Yeah, I've got different varieties of images with different damages. Okay, so I have like about 12 of them. So I'll copy them. The first step is to copy them into an S3 bucket, which is I've already done that. So I've copied them into the S3 bucket, and we'll get the pipeline to read the files from this bucket and get the analytics out of it. Okay, once the files are in the S3 bucket, let's switch over to Snowflake. Okay, as I mentioned, like anyone who worked with Altida, they know that it's a metadata-driven tool. Okay, so I've just created an entry in my extract meta, I've tagged it against this particular source, which is a logical identifier. I'm saying these are all the JPEG files that are sitting in my S3 bucket, and that's the folder name. Okay, but the crux here is actually the prompt. So we want to give the data engineers the ability to create their own prompts, and that has to sit outside the pipeline, so it's not hard-coded. So you can see the prompt is actually stored in a column called SQL snippet. I'll just quickly show you the prompt. Okay, this is how the prompt looks like. So I won't go through all the details, but what I'm saying is I want the AI to spit out the results in a strict JSON format with all these attributes being captured, right? That's what I'm saying. And I'm also telling the model to give its confidence level as it analyzes the images, right? So this is the prompt that I have configured in my extract meta. Once that is done, that's pretty much you're required to do from the Snowflake analytics side, from the Snowflake side. Now let's switch over to the OpenFlow. So this is a Snowflake native data ingestion tool. Okay, and we have already built a pipeline for image analytics. So all I'm doing is just clone the pipeline, which I've already done. Right-click on the parameters and change it to the source name that you have configured in your extract meta. So which I've already done. Like this is the source name that I have given in my extract meta entry, and that's pretty much it. And then just go and run the job. Okay, so now what's happening is OpenFlow is actually talking to the Snowflake, reading the prompt out of that extract meta table, passing it on to the AI wrapper model that we have created, spitting out the results into the data lake, and then Altida will pick it up, and then it will store the results into a stage table. Okay, this is all happening behind the scenes. So let's see. Let's query the run queue. Okay, so as you can see, Altida is actually creating run plans for each of those images in the S3 bucket. Okay, this will take like a minute or two for the analytics to be collected. While this is happening, and the results will be available in the next 2 minutes. So rather than looking at the boring JSON, what we can do is let's visualize these results as they're available using a Streamlit application in real time. So we have a Streamlit tab here. Okay, and these are all the images that are coming from my S3 bucket. So I just click on Analyze Images. If the results are available, then you can look at the operational report straight away. Okay, so let me see if the results are available for this. Yep, we do. So as you can see, like it has actually analyzed this image, and the model said that its confidence score is 85%. The severity is high. It's based on the impact of damage to the car. And then you can see that definitely the car is not drivable and it requires towing. And it even picked up some attributes of the car like color, the model, etc., and what type, whether it's a sedan or hatchback, and some additional details like what components of the car have damaged. For example, in this case, the front bumper has damaged, and the damage is quite severe. And then you have headlights damage, whatever. Yep, I'm not going to go through all the details, but we have the results for this as well. It knows that the headlight is damaged. It even picked, it couldn't figure out the color or whatever it is, but it knows that headlight is broken. This one is interesting because visually I can't see any damages. It looks brand new. I don't know if anything has happened on the other side, but let's see what AI has come up with. Yep, confidence score is 95%. Severity is low. It thinks like the car is drivable. It doesn't require towing or anything. And it even picked up the color of the car, the make, and whether it's convertible or whatever it is. And then it couldn't find any damages. I'm not going to go through all that, but you get the gist of it. Like, how quickly we were able to analyze the images, like, using AI and put it through and streamline the whole processing through the pipeline. Okay. All right. And Cortex AI SQL, it's not just about analyzing the images. You can do a lot actually. So in this case, like, I have a variation of the complete function where I can compare two images and say whether these two images, do they refer to the same car or a different car. I won't run it. It takes like about 60 seconds or whatever, but this is how you can do it. And one interesting thing is you can pick a source image. For example, in this case, I picked up one.jpg from my S3 bucket, and you can compare that image with the repository of images and tell the model to pick up all similar images with a similarity score greater than 50% or whatever. So let me run this because this is interesting. And there could be tons of use cases around this. Okay, so as you can see, I have compared one.jpg with like about 12 images in my S3 bucket and then came up with the similarity score. So you can see one is compared against one and the similarity score is 100%. But whereas with other images, you can see the similarity score is like 49, 72% or whatever it is. And you can also classify the images on the fly. For example, in this case, 4.jpg, which is, let's see what 4.jpg is. Yeah, it's this car. Okay. And I want to classify this image on the fly, whether it's a sedan or SUV or ute. And model can do it. So different types of variations available when it comes to the complete function, and you can do a lot with the image analysis. I'm pretty sure there are tons of use cases out there that we can solve for the customers. That's pretty much it from the image analytics side.